Hello class, welcome to lesson 5.6a, factoring polynomials. Just want to remember that last day when we had our lesson and we were trying to solve a quadratic, we used some factoring techniques. We're going to take some more time in the next 2 or 3 lessons to go over the different types of factoring to make sure that you have mastered these, okay? So first of all, we want to talk about factoring, and remember that factoring is the opposite of expanding. So if I was asked to factor, I could check using expanding. So check by expanding. Likewise, if I was asked to expand, I could check by factoring, because these are opposite calculations. Okay, so if I have this expression, it'll usually say expand or simplify. So I'll just put expand on top of it. Okay, so when you expand, use distributive law. Hopefully you remember distributive law means whatever you multiply, whatever's out front of the bracket gets multiplied inside. So this is 5x minus 15. Okay, so this is the expanded form, and going the opposite way is factored form. So if I gave you another example and said factor 5x minus 15, you would say, hey, what's common in both 5x and negative 15? 5 can be factored out. Whatever's left over goes as to become the other factor. So if I divide the first term by the first term here, if I take a look at 5x, do it on the sideboard, and I divide by 5, I'm left with just x. And if I take my second term, negative 15, and divide by 5, I'm left with negative 3. Okay? So when we take a look, ladies and gentlemen, these are what we call our factors. And we started with what was called the product. That's the opposite of the question above. The question above, we started with our factors, 1 and 2. And when you expand, you end up with the product. All right? All right, so let's start by practicing common factoring. Okay, to common factor, you need to see what is divided out into each term. And we call this the greatest common factor, short form GCF. And we use that and divide every term by it to get the greatest common, to get the other factor. So factor completely. Okay, here's a couple hints. Look at the coefficients and look at the common variables using the lowest exponent. Okay, so looking at example A, I look for the numbers first. What goes into both 3 and 6? And that is 3. And I look to see, do my variables occur in both terms? Yes. And you take the lowest power exponent, so it's going to be 3x to the power of 1. Dividing both terms by 3x. So if you do it in a margin, if you need to do this work, by all means do it. If I take that and divide by that term, I can cancel out. 3 goes into 3 once, it goes into 6 twice. Using exponent laws, 2 subtract 1 will clear that out, so you're just left with 2x. Do the second term, negative 3x divided by 3x. Well, hey, the 3's cancel out, the x's cancel out, so we're left with negative 1. All right, moving on to a harder question. B, looking at this, look at our coefficients. Do we have a number that goes into both 14, 7, and 2? Not this time, so we can look for our variables. Does every term have an m? Yes. What's the lowest power we have of m is m to the power 1, which is in the second term. And then we look for our n's. Does n occur in every situation or every term? Yes. And the lowest n we see is n to the 4th. Okay. You could leave it as m to the power of 1, or you can just leave it as m. Okay? Because m understands that it's m to the power of 1. So that's our greatest common factor. We're going to divide every term by mn to the 4th, and we're left with 14mn. Use your exponent laws. Divide by means to subtract the exponents. So subtract 7 n plus 2 m squared n to the 3rd. Okay? So there's our two factors. Last, oh, sorry, keep going here. Last question C for this part. Looking at here. Now you got to be careful here. This one's kind of tricky. As I look at the numbers negative 12, negative 4, and negative 6, all three are negative. So if all three are negative, you got to take the negative sign out. Okay? Then what we need to do, ladies and gentlemen, is take a look. What's the greatest number that goes into 12, 4, and 6? And that is 2. And then we look for x's. Are x's occurring in each term? No. Are y's occurring in each term? Yes. Are z's occurring in each term? No. Okay, and then when we finish this, we're going to take a look. So we have negative divided negative is a positive. 12 divided by 2 is 6. X squared, and the y's cancel out. Plus 2z and plus 3xz. All right. Now we have to take a look at another type of common factoring. Sometimes a whole bracket is common. So taking a look at, oopsie, sorry. Let me expand that up, okay? Taking a look at D, for example, notice that x plus 7, it's actually a binomial in this case that is common. So you put that out first, and then you take the leftovers, which are really the products, and they become one group. Okay, you should remember this is a step that you did when you had did a decomposition, which we're going to get to a little later. But that is, again, what you do. If you're not sure how that works, if you take the first term, which is x minus 7, and you divide through by what's common, x minus 7, notice that these cancel out, and you're left with x. Do the same for the second one, plus 3 x minus 7 divided by x minus 7. Notice that that bracket cancels and you're left with the plus 3. All right. Try the next one. Give it a try on your own. You should hopefully get m plus 8 times m minus 4. Great. Let's go to the next page. Now we're going to take a look at simple trinomials. For simple trinomials, that is where a equals 1. And in this case, when you say the product, which is a times c, since a equals 1, in this case the product is just c. Also, we notice that the sum is b. Just remember, it's based on the standard form, y equals ax squared plus bx plus c. Okay, in this case, a equals 1. Okay. So taking a look here, just to classify this, for a equals 1, because 1's right here. B equals 2, because it's in front of A. And, sorry, C equals 1. Depends on what teacher you've had in the past. For me, I always go product equals 1. Sum equals 2. And then I figure out what two numbers add to 2 and multiply to 1, and it's 1 times 1. So then you would go a plus 1, take the sign of each factor, and because these are the same, you're going to say a plus 1 squared. If you recognize that as a perfect square right away, go ahead. Otherwise, I'll show that to you a little later, or ask me in class and I can show you the short form for that one. Okay. Next one, taking a look at this. Product equals negative 18, and the sum equals negative 3. First of all, if the product is negative, you know there's one negative and one positive value, okay, that are going to give an add to this. So think of the products of 18. You got 1 and 18, you got 2 and 9, and you've got 3 and 6. It's negative 6 and positive 3 that are going to give you those answers. So then you go m minus 6, and the sign are important because it's the sign is whatever's attached to your factors here. So it's m minus 6 and m plus 3. You could have written it down, if you did it in the other order, you could have written it down m plus 3 times m minus 6, and the answer is still correct because a times b is the same as b times a. All right, 2 more. Let's see if we can get them done here. Okay, If you want to stop and pause the video and try these on your own, that would be recommended. And then unpause and I'll do the answers. Okay. In this case, we've got a product that's positive and a sum that's negative. That tells us that both numbers or both factors have to be negative. So what times what multiplies to 40 and adds to 10 or 14. So that's negative 10 and negative 4. So hopefully you have n minus 10 times n minus 4. Last question. Off to the side. Product equals negative 9. Sum equals 8. We've got to have one positive, one negative. So it's going to be negative 1 and 9. So this is going to equal x minus 1 and x plus 9. All right. Any questions there, folks? All right. Now we're going to take a look at combining two things. Sometimes you need to common factor the trinomial first. In fact, it is usually best to do so, and you'll get deducted errors if you don't do it at the beginning. So when it says factor completely, the completely part should tell you to common factor first, if you can. Or there could be two different types of factoring. Okay, let's start with common factoring. So look at example A. What's common to all three terms that we can factor out? It's a 3. So you'll be left with x squared plus 7x plus 12. Then what you need to do is say, hey, I've got a trinomial left over, so I'm going to figure that out. So product equals 12, sum equals 7. What two numbers do we have? 3 and 4. So you have x plus 3 and x plus 4. All right. Taking a look at the second example. Looking at it, you should recognize that we can divide everything by 5. So you have a squared minus 2a minus 15. And make sure when you do your product and your sum that you use the values inside your bracket. Okay? Because now you've made it into, once you've common factored out, now it's a simple trinomial factoring. If we started with the original question and started factoring that, we'd have to do what's called decomposition. And we will get to that in the next lesson. Okay, so for now, we're going to take product equals negative 15. Sum equals negative 2. What two numbers do we have? You should have negative 5 and positive 3. So leave the common factor out front. Go a minus 5 and a plus 3. All right. This is a hard one, ladies and gentlemen, but we can do it. Notice that this is an awkward looking question. Okay, we've got a monomial times a binomial, subtract a monomial times a binomial, plus a monomial times, or a constant times a monomial, or a binomial. So it's pretty big, but what do we recognize? Hopefully you see something common in each case. So what's common in each case is m plus 2. Put your leftovers, which are still your products that you would have to divide through. So it'd be m squared minus 5m plus 6. Notice that this is a trinomial here. So we're going to keep working that out. So we're going to get two brackets here. So in the rough work, product equals 6. Sum equals negative 5. So what do we have here, ladies and gentlemen? Hopefully you get negative 2 and negative 3. So you have m minus 2 and m minus 3. All right, there's a good practice of factoring. None of this should be new. This one might have been a little more difficult to get started, but hopefully you would recognize that you've got to do common factoring of binomial and then simple trinomial factoring. Here's your homework, folks. Page 103, numbers 1 ABC, 2 ABC, 3 ABC, and 5 part A, or part 1, 2, 3, and 6 ABC. Have a great night and come and see me if you need some help. Good night.